machine learning, you'll be meeting a lot of columns and tables or matrices that you'll be working with, various versions of it. One of them that also comes or shows up mostly is one that most of the data is filled up with zeros. For example, you have a matrix. Let's say you have a matrix 0, 0, 0, 0, 0, 1. Then you have 0, 3, 0, 5, 0, 0, 0, 0, 0, 0, 6, 0. So most of the data is filled with 0, right? So this one, the only valuable data that where elements are at this point 1, 3, 5, and 6. They may be longer than this, that the values that you need, the value that's where non-zeros elements are at a very like only critical positions in the entire matrix. The matrix that will be meeting mostly will be larger than these ones, and then there is some form of matrices or data that will be having in such a way that a large portion of it will be filled with 0, where and there will be very few non-zero elements at some point, right? So how do we handle this kind of matrices, or is there a way that we can actually visualize and locate this in elements? What if we can locate these elements differently? So we have row 1, row 2, row 3, right? If you are looking at it like this, so this is row 1, row 2, row 3. And if you go to this column 1, column 2, column 3, column 4, this one, column 5, and then we have column 6 here, right? So for example, let's try to locate this element. So this element is where so it's just going to be like x and y axis, right? You have to the row, which row is that? It's going to be in row 1, right? So it's 1 comma which column 6. This is column 6. So at 1 6 we have the element 1, right, as in row 1 and column 6. So row 1 column 6 we are having the element, so let's say value here, the value will show here, right? So another one is let's try to locate the number 3. So for the number 3, so the number 3 will be which row comes first? So row 2, column 2, right? Row 2 column 2 we have the value 3. So and this one we are going to be at, it's still row 2 column 4 we have the value 5. Then we locate this one at row 3 column 5 we have the value 6, right? So this is what we are trying to do. We are trying to transform this matrix into a sparse matrix. So the sparse matrix is basically this one filled with 0, then you convert it into this form that you can now see the various elements or non-zero elements and their positions. Now in programming, in most programming, we actually don't start counting from 0. We actually don't start counting from 1. We actually count from 0. We start counting from 0. For that matter, when you say row 1, row 2, row 3, you have to actually have from row 0 to row 1 to row 2. So a column is going to be column 0, column 1, column 2, column 3, column 4, and column 5. Right? Even though there are 6 elements, the counting starts from 0. There are 6 columns and 3 rows, but the counting starts from 0. So we count column 0, column 1, column 2, column 3. But the number of elements actually is 6 columns. And for the rows, there are 3 columns. But when you are counting, row 0 always counts. So it's just like indexing. So row 0, so this one is actually row 0, column 5. This one's row 1, column 1. This one is row 1, column 3. This one row 2, column 4. That's how we actually see it. So this is what we are going to call the sparse matrix. It's going to be very helpful when if you meet a data that is containing a lot of zeros and few non-zero elements. Let's go back to our Jupyter and see how to do that. Okay, so here we are going to have an example of a sparse matrix that we have, right? So first, let me have matrix equals to, so you know we have to be a list in a list, so we have 0, comma 0, comma 0, comma 0, comma 0, 1, 2, 3, 4, 5, comma 1. That's what we had, right? And another matrix, another row, 0, comma 3, comma 0, comma 5, comma 0, comma 0. So yes, next one, 0, comma 0, 0, comma 0, comma 6 here, comma 0. This is what we have in the third row as also, right? So this is just the matrix, but we need to convert it to NumPy matrix. So we have to import NumPy as NP, right? And from there, we need to form the NumPy matrix here, form the NumPy matrix, right? So to do that, we are going to have, so let me call this matrix list so that you have the difference. So matrix list. Now we have to convert to an actual matrix using np.array, right? Then you put the matrix list inside. We've done that in the previous session. Now here, let's just print matrix. So we print matrix. So we have the matrix here, right? But then there are a lot of zeros. This is 0. This is a kind of something that we can convert to a sparse matrix. But how do we do that? We have to first go and import something from scipy. We have to import from scipy import sparse. This that we need that module to convert it to sparse. Now what we do is that we now use the sparse there. So I'm saying this is a sparse. So sparse matrix over here. Then we say, let me call it matrix underscore sparse. It's going to be equal to sparse dot csr underscore matrix. It's going to be the matrix. You put in the matrix itself here. Then over there, now we print the sparse matrix. So matrix underscore sparse. Now we have the sparse matrix given us. So what do we have here? 0, 5, right? Row 0 at column 5, we have the element 1. Row 1, column 1, we have element 3. Row 1, column 3, we have element 5. Row 2, column 4, we have element 6. This is how you convert a matrix that is filled with zeros, a very few non-zero elements, and then you have the matrix itself. Then you use the sparse from the scipy to convert it to the sparse matrix, and then this is how it will give you, it will sparse it and give you something like this, so that you handle or focus more on the location of the non-zero elements.